A very good morning, evening, or night, ladies and gentlemen, depending on when you're watching this video. I'm Sam from the Swinburne Civil Department, and I would like to ask, what's the first thing you think of as a material for construction? I would say most people would answer concrete, and hence, here I present you my topic, which is the environmental impact assessment of concrete with different mix designed in Sarawak, Malaysia through a life cycle assessment approach. So, over the years, increased population has caused a huge demand for rapid infrastructure development. This rapid development in the construction sector has caused several environmental impacts. For instance, global warming. Concrete, as one of the core ingredients used in the construction industry, is also the main contributor of greenhouse gases emission. This is also reported by Lee, who said that the building sector consumes large amount of resource and contribute about 36% of the world's carbon emission. Not to mention, the construction industry is also one of the important industry that stimulates the national economic growth, GDP. This is especially important in developing countries because construction activities affect multiple aspects of the economy. Currently, Sarawak, especially Kuching, is developing fast, and hence a sustainable development using materials with less environmental impact is important. There are several existing ways to reduce the environmental impact of concrete. For instance, using supplementary cementitious material or SCM in short. SCM are materials such as fly ash and blast furnace slag. These materials exhibit pozzolanic properties which react with the cement. However, the level of environmental impact is unique to each specific region, and studies related to this have not been done in Sarawak. Hence, led to the problem statement for this research topic. How and what is the environmental impact of processing and manufacturing OPC concrete and concrete with SCM in Sarawak? The aim for this research topic is to evaluate the environmental impact of different SCM as partial replacement of cement through a methodology known as the life cycle assessment approach. So now you might think, what is a life cycle assessment, or in short, LCA approach? LCA is one of the most widely used environmental impact methodologies due to its integrated way of accessing the framework, impact assessment, and data quality. It is a methodology aimed towards evaluating the environmental burdens of processes and products during the entire life cycle. The life cycle can either be from cradle to gate, which means from raw material to factory gate, or from cradle to grave, which means from raw material to end of life. The LCA is also often used as a supporting tool for decision making because of the system's nature to allow processes and materials to be compared. Through LCA, the research objective is to investigate the environmental impact of OPC concrete and concrete with SCM, such as blast furnace slag and fly ash in Sarawak. Through this research, the team aimed to 1. Reduce the environmental impact of concrete used in Sarawak, 2. Encourage the usage of industrial waste, and 3. Promote a sustainable development in Malaysia. Literature review has been conducted for 12 research papers. Due to the limitation of this presentation, only 3 papers out of the 12 papers have been selected to best represent the research area. Okay, let's start with the first graph by Tosti, which shows the comparison of fly ash concrete to OPC concrete. The specimen studied is 2 different fly ash replacement percentage, namely 20% and 40%, of 2 different combustion methods. The potential environmental impact is evaluated in 4 major impact categories, which are namely global warming potential, human carcinomic and non-carcinomic toxicity, and ecological toxicity potential. From the research, it can be found that cement with fly ash mixture generally perform better than the reference OPC in terms of global warming potential and the human toxicity category. As shown, higher percentage of fly ash replacement may not necessarily outperform lower percentage fly ash replacement, as the concrete compressive strength is comparatively lower at 28 days. Hence, additional cement is accounted for the 40% fly ash replacement to achieve a similar compressive strength as the 20% fly ash replacement. Moreover, it is shown that the fly ash produced from different types of boiler will have an impact in the end result. Okay, next. This is a study by Lee. Blast furnace slag is used as a SCM in producing concrete. From the study, concrete with 10% slag replacement generally outperform the reference OPC concrete in terms of every impact category except human toxicity potential. However, the overall total average is still lower, which is a good indication that SCM as a replacement is effective to reduce the environmental impact. Okay, next. The third study is by Asodala Fradi. In the study, it highlighted the main processes which have the most impact on environment. Generally, the production of cement has the most environmental impact because of the intensive energy required to process the clinker, which is the core ingredient to make cement. This is followed by the energy used for production process of concrete, general transportation, and lastly, the preparation of gravel and sand. Now, as an overview of the methodology, the LCM methodology can be differentiated into 4 main steps according to ISO 14040. The first step, which is goals and scope definition, is focused on allocating appropriate functional unit to be used and refining the system boundaries. Hence, this aid in delimitation of study areas. The second step is life cycle inventory analysis, which involve data gathering, data conversion, data validation, data input, and computation using specialized modeling software. In this case, is the OpenLCA software. The third step is the life cycle impact assessment. At this step, the suitable impact analysis method, either problem-oriented or damage-oriented, have to be determined and used for the software to perform modeling. The common impact category are usually global warming, human toxicity, acidification, and ozone depletion. Lastly, the final step is the life cycle interpretation, which uses the data obtained to provide a conclusion, limitation, and recommendation to assist the user in decision making. For instance, to select the concrete mix design with least environmental impact. Alright, as for future works, as mentioned, the data obtained will be evaluated through computational modeling, and the analyzed result will go through a critical review as described in ISO 14040. Before I end my presentation, I would like to thank my supervisor and co-supervisor Dr. Chin and Associate Professor Vincent for the guidance and support. And lastly, thank you all for today.